book. And then the last quantity, so it's not that hard to turn volumetric flow rate into mass flow rate. So if volumetric flow rate is meter cubed per second, then mass flow rate is like kilograms per second. So the only conversion factor you need to do that is you need to know the number of kilograms that are per meter cubed, right? So the density. So if you just insert an extra factor of density in that integral, then the mass flow rate can be calculated that way. Most of the time in this class, I actually don't know if there are any exceptions in this class, including, I don't know, maybe I think there are some exceptions in the compressible flow chapter, but with the exception of the one compressible flow chapter near the end of the book, I believe everything we'll do in this class will be for an incompressible fluid, where you can just take the density out of that integral. And probably the most common way, so like if you look at what happens, obviously if you take density out of the integral, then that entire integral is just the volumetric flow rate again. So that would be density times Q. And of course, if another way of writing that, since Q is just the average velocity times the cross-sectional area of like a pipe or something like that, a lot of times it's convenient to write the mass flow rate as rho VA, where V is the average velocity. So I think a lot of times in the class we'll probably write it in the very last way. We probably won't go to a lot of trouble to write the integral out, unless there's some reason why we don't know the average velocity. So this is the most common way that we'll write things out.